Hello and welcome to an introduction to the Manufacture Workspace in Autodesk Fusion. Now the Manufacture Workspace is where you're going to be making toolpaths for machines. So a wide variety of different kinds of CNC machines. And we're going to be kind of focusing on CNC mills and routers. So why don't we get started? Okay, so if we take a look at Autodesk Fusion when we open it up, we are by default in the design workspace. We're going to switch over to the manufacture workspace. Okay, so right away, let's take a look at, mentioned the different types of machines you might be programming for. And at the top here is kind of a list of different types of environments, so kind of sub-environments of the manufacture workspace, where you can make toolpaths for different types of tools. So right now we're in the milling, which is where we're going to spend a lot of our time. There's turning, and this is for programming for CNC lathes. Additive, and this is where you program for like 3D printers. A lot of 3D printers have their own software, but kind of specialty printers will need toolpathing to be done in a different software. There's inspection. This is for kind of making probing toolpaths, things like that. Fabrication is where you'll do things like set up for 2D profiles for cutting in laser cutters or water jet cutters or things like that. And then utilities is where kind of you manage your tool libraries and machine libraries, all those kinds of things. So we're going to start in the milling section. Right away I noticed that my units are in millimeters. I'm going to change that to inches. And the reason I'm changing those to inches is because really my tooling is in inches. So all of the cutting tools that I have are in inches, and so that's why it makes sense for me to work in inches. If you are working with millimeter tools, probably best to leave that in millimeters. Okay, so if you look along the top row of this milling section of the manufacture workspace, the first area is setup. And if we expand that menu, we can see we have places for making new setups, creating NC programs. This is kind of where you're going to start. You're going to always start your CNC program with a new setup. Then in the 2D section here, we have a list of potential 2D toolpaths. And what a 2D toolpath is one that while it's being executed, while it's being machined, all of the movement happens in X and Y. So it's a dynamic X and Y movement while the toolpath is happening, but not a dynamic Z movement. So machines that have Z movement capabilities can do 2D toolpaths. And usually what happens is the 2D toolpath is used to position the tool to the correct depth, and then the 2D toolpath executes at that depth. So these are a list of different types of toolpaths, and as we go through the projects, we are going to use all these different toolpaths at different times. The next section is the 3D toolpaths. So they really separate these 2D and 3D toolpaths because they are quite different. 3D toolpaths are primarily used for finishing we call 3D surfaces. 3D surfaces are ones that have kind of a dynamic Z. So that means kind of like maybe like a curve that happens in Z, so that in order to make that toolpath, the machine needs to move dynamically in X, Y, and Z simultaneously. 3D toolpaths are, not every object that you make is going to have a 3D surface that needs 3D finishing. But if it does, you will find it in the 3D toolpath here. Many parts are just 2D toolpaths or just have a collection of different 2D toolpaths. Any part that has multiple 2D features at different heights is known as a 2.5D part. So that's a very common 2.5D part. Then, you may have a 2.5D part that has maybe 1 or 2 3D features, or you might have an object that is like all 3D features. So there's a kind of a wide variety, and depending on what you're working with, you'll be choosing things from different menus here. But they are quite different. The strategies for 2D machining are quite different than the strategies for 3D machining. And we'll get into that, and we'll kind of cover that as we go through the projects. Next section here is drilling, and this is for creating drilling toolpaths. Also for kind of any type of toolpath that doesn't have any XY motion. So like a drilling toolpath or a tapping toolpath if you're kind of cutting threads into a material. The tapping will be in here, boring, some boring operations will be in here as well. Then we have multi-axis. This is for things that require additional axes of rotation and movement. This is really kind of advanced stuff. This is 5-axis stuff, 4-axis stuff. Essentially, whenever you have a machine that has, say, X, Y, and Z movement, if you were to enable rotation around X, for instance, that would be one more kind of axis. That'd be the A axis. If you were to be able to have the machine rotate the entire Y axis around, it would be the B axis. So kind of adding these additional rotational axes gives you more access to different parts of the part, but it makes it a lot more complicated. So that's the multi-axis section, and we will have multi-axis parts that we go through, but that's quite advanced. So we're really going to start with 2D stuff, work through our 3D things, and drilling will be definitely a part of that. Then the more advanced ones will be the multi-axis parts that we use. It requires that you have a machine that's capable of doing this, and not all machines are capable of doing multi-axis machining. So modify section, this is where you can kind of make specific changes to toolpaths after you've made them. The action section is actually quite important. We're going to be using, as we go through each project, we'll pretty much be using each one of these options. Generating for creating G code, or for refreshing toolpaths, for updating toolpaths once changes are made. Simulation, we'll do a simulation after we make every single toolpath just to make sure that it's exactly right. Simulate with machine, which you can do if you have a machine model, but that's kind of an advanced technique. Post-process, where you make the G code from your toolpaths. A setup sheet is where you have all the details of your program for the machinist who's going to be making that. Machining time is kind of like an estimate of how long it's going to take. The manage section here is, we'll spend a lot of time in here as well. This is where you will create your tool libraries and manage your tool libraries. Having accurate tool libraries that represent, accurate digital tool libraries here that represent physical actual tool libraries that you have in your shop are really key, because the program is only going to be as accurate as your tool library is accurate. If your tool library deviates from, if your physical tool library deviates from your digital tool library, you can have some serious problems. So we're going to spend a lot of time developing really accurate tool libraries. There's also the potential for machine library. So you can have a 3D model of your CNC machine that moves as your machine would move during machining. This is a bit more advanced, but we will get to this, and we'll kind of, for some of the programs, we will have our machine in there. It's not necessary, but it does add another kind of visual verification layer, and it's particularly important if you're doing multi-axis stuff, because there's so many more potential collisions that could happen between all the other new moving parts of the machine. So the other thing about this is that, just like with the tool library, the machine library is only as useful as it is accurate. If you have an inaccurate digital model of your machine, or the movements of it aren't exactly as they are in the machine, then you may get results in the simulation that aren't representative of what's going to actually happen in the machine, and then it's not useful, and it can actually lead you to maybe be overconfident in some things. So machine libraries are great, but they have to be really really accurate. Inspect is where we'll do things like grab our measure tool, do section analysis, and things like that. Okay, so that is the kind of basics of the manufacturer workspace for the milling. One thing that I'll talk about here, let's talk about the browser. So the browser is going to be really important. It's a little bit different than the browser in the design environment, but not that different. One of the big things is that you have setups here as well. So if you say, I'm going to make a kind of just a fake setup right now, make a new setup, click OK. Ignore the warnings. So normally if you had a model, it would be in here, and then you would make a setup around that model. So now you have this setup section, and this is where your setups will show up, and then underneath each setup will be your list of toolpaths. And it kind of works similarly to how it works in the design environment. You can turn the visibility of your setups or your toolpaths on and off with this eyeball here. There's a check mark right here next to each setup and also next to each toolpath, and it'll let you know if there are any problems or issues with that setup or with that toolpath. You still have access to all of your models, so all of the objects inside of your model here, and a lot of times it's going to be important to be able to turn on and off the visibility of different bodies or different components depending on what you're doing. So that is in there as well. Yeah. And I think that's basically it for the fundamentals. Once we get into the projects, into project 1, project 2, we will start to be able to use these things, make setups based on 3D models, and then make a series of toolpaths, and then generate G-code. We're going to simulate all of our toolpaths to verify them, and then generate G-code, make setup sheets, and all that. But we'll get into that when we get into the next projects. So take a look at the next one, and we'll see you there.